Everyone. My name is Tristan Scott. I'm a product marketing engineer with our Buck Switching Regulators WideVN team. And as Emily mentioned, the topic of today's new product update is going to be using high-density WideVN buck converters to solve your industrial design challenges. So thanks everyone for tuning in, and we'll get started. So for the agenda today, just a quick introduction on what it means to be a WideVN switching regulator in our terms at Texas Instruments, a bit of package technology evolution, as that's going to be kind of the focus topic of this discussion, the package technology behind our new power dense buck switching regulators. And then we're going to go more into the specifics of newly released and newly sampling power density leaders in our portfolio, do a package size comparison as well as a solution size comparison to previous generation switching regulators. And then we'll go into the specific device overviews as well as their specific value propositions to help you better understand what from our portfolio can best fit for your design need and solve your design challenges. So starting off, we at TI call our WideVN DC-DC buck switching regulator portfolio as anything greater than a 30-volt maximum input voltage. So that includes converters, controllers, and power modules. So we offer different varying levels of integration, with the least being the controllers, and then the most being the buck modules having the integrated inductor, and of course the converters in between with the integrated FETs. We also have an isolated DC-DC flybuck and PSR flyback portfolio, but we're not going to go too much into the isolated portfolio today. And our focus markets or applications for WideVN is automotive, industrial, and communications. Today we'll be focusing more on the industrial piece, focusing on our commercial grade devices as well as the modules. But usually these are servicing 24-volt rails commonly and 28-volt for aerospace and defense. And in the automotive market, that does vary from 12 to 48 and 24 to 48 in the communications market. What are some of the system benefits you can get by using a WideVN buck converter, controller, or module? Well, the WideVN operation, of course, gives you a little more headroom on your input voltage rail. We have devices in the 36-volt space commonly, and we have an emerging 60-volt portfolio, as well as plans to go even higher, and we have some isolated portfolio at 100 volts. We also have high efficiency at these high input voltages, the ability to switch up at 2 to 2.2 megahertz, which I'll talk a little bit more about, as that allows you to shrink your total solution size and get a more power dense total solution. We focus a lot on low IQ performance to get high light load efficiency, as well as an extended battery life. And of course, meeting your EMI performance specs, as EMI is always an area of interest for the designers, and whatever standard you need to comply with, we provide documentation and easier ways with varying levels of integration and layout reviews to help you meet your EMI specs as needed. So knowing what a WideVN buck regulator is now, I kind of want to dive more into the specifics of the package evolution that is going to align with our focus on driving the most power dense solution for your buck regulator needs. So this is kind of a cool chart that provides a little history and a look back at our package technology over the years. So starting with the HT SSOP package, or our leaded package, back in 2014, this is what we called our 6th generation of WideVN buck converters. And this was kind of before we put a large focus on reducing the package size and power density. And it was more so for the ease of use perspective of the leaded package. And we still do have a lot of leaded packages in our portfolio today, but we're also, as you can see, putting a lot more focus on the non-leaded packages to get the most power dense solution. So moving on, in 2017, we released the WSON package with the LMR 23630 in a 3x2 or 3x3, millimeter size. So a significant reduction and removing the leads from the HT SSOP package in the previous generation. We also added a large thermal DAP, and that really is our first focus on having a more power dense solution. So moving on from there, we kind of took that same motivation in power density, but also taking EMI into consideration, we released the Hot Rod QFN package, where we have the flip chip on lead option, and we eliminated wire bonds, most importantly, to get better EMI performance. And as you can see in the graphics above, with the lack of wire bond in the generations in the steps compared to the HC SSOP and WSOM package, and that does lead to a improved EMI performance. This package we released with the LMR 33630 and 36015 was in a 3x2 millimeter package size, so smaller than the WSON. And since then, I will be talking more specifically about a device, the LMR 36506, we have recently released in a 2x2 millimeter Hot Rod QFN package. We also have the option to add wettable flanks on a lot of these Hot Rod QFN devices for visual inspection needs. So moving on from there, how do we kind of make a more power dense solution after already releasing a 2x2 millimeter package? It kind of gets tough when you're pushing the boundaries of power density to improve the total solution size. And what we came up with, of course, is having an enhanced Hot Rod QFN package. So it's a lot of the similar aspects and technology of the Hot Rod QFN device, except we're putting more emphasis on the improved routing and thermal capabilities of this package. And that allows for higher power density with the better thermal performance, because we can obtain higher output currents with less derating, as opposed to the previous generation Hot Rod QFN. So it's not necessarily shrinking the package size, but increasing the capability of the package technology that allows us to have a more power dense solution for your needs as a design customer. And then moving on from there, we are putting even more emphasis on EMI performance as well as total solution size reduction. So we take the enhanced Hot Rod QFN package, and now even for our converters, we are integrating high frequency bypass capacitors to not only improve the EMI performance, but also reduce the need of capacitance in your total solution design, thus reducing the solution size. And then with the same package technology, the enhanced Hot Rod QFN, we have for the power module, we are integrating both the capacitors and the inductor. So of course, the power module will be your highest integrated solution. It'll provide the smallest total solution size, the best EMI performance, because the input capacitors that we're integrating are very close to the input switch and switch node, reducing EMI performance. So we're furthering our module portfolio, especially in the wide VN space, and we're excited to see where this new package technology, the enhanced Hot Rod QFN, and the integrated caps along with it, which has been released in the last 1 to 2 years as a new technology, will take us in our portfolio. So moving on to talk a little bit about the specifics of this enhanced Hot Rod QFN package that I keep talking about. So it's both optimizing EMI and thermal performance. The EMI performance comes from the nature of it being similarly Hot Rod QFN package and having no bond wires, thus reducing the switch node ringing. And we've seen that on our LMR 33630, the first generation Hot Rod QFN package. What the real benefit of the enhanced Hot Rod is in the thermal aspect of it. And as you can see on the chart to the left, which is comparing the max output current versus ambient temperature that the buck switching regulator is operating at, we compare the LM60440, which is our first converter released in this enhanced Hot Rod QFN package, to the previous generation LMR 33630. And with the same silicon, we're able to achieve a higher output current, 4 amps versus 3 amps peak output current, at higher ambient temperatures. So the derating, the bend in the derating is not happening until 5 to 10 degrees T ambient higher with the LM60440. So when you're considering power density, like I mentioned, you're able to get the higher output currents with less derating. So instead of having to go another size up in package, which you would have if you needed 4 amps at 80 degrees C ambient beforehand, before the LM60440 released, now you don't have to, and they're both in a 3x2 millimeter footprint, so same package size. That kind of summarizes the main benefits of the enhanced hot rod QFN package on the thermal aspect of it. And then from a manufacturing and reliability standpoint, we have also added wettable flanks to guarantee visible side wetting and good solder joints and visible inspection, which is often a large concern for some customers. Having corner pins with the nickel cadmium gold finish improves the BLR performance. And as you can see on the graphics below, how the wettable flanks can improve the visual inspection. But as we release more and more devices in this package technology, the reliability and the quality will only continue to improve. But so far, this shows that we're putting a lot of emphasis into the manufacturing capabilities of the new package technology to de-risk any customer that might be a little bit apprehensive on jumping the gun on a brand new package. So moving on to some specific devices and comparing package size across the portfolio of these new devices that we really want to highlight with this discussion. And we have quite a variety in output currents and the input voltages, as well as the package sizes, comparing both converters and power modules here. So looking to the right, you can see that the largest package size here would be our power module, the TPSM 53604 and TPSM 5601R5H. The TPSM 53604 is newly released, and the latter is newly sampling publicly on TI.com, which is a 36-volt 4-amp device and a 60-volt 1.5 amp device in the same 5 by 5.5 millimeter footprint. So this is integrating the inductor in a 3D stilted construction, and is hence why it would be the largest of the packages that we want to highlight here, because it integrates the inductor along with it, and it's going to provide the total smallest solution size for 36-volt 4 amps and 60-volt 1.5 amps. And then going down the arrow here, we have the LMQ61460, which is a 36-volt 6-amp device in a 3.5 by 4 millimeter hot rod QFN package, but it also integrates high-frequency capacitors within the package. So we're taking the next level of integration there, and I'll talk more specifically about it, but we're able to get out 6 amps of output current in the converter package in a 3.5 by 4 millimeter size. And then I mentioned the LM60440 being our first enhanced hot rod QFN converter. That's in the 2 by 3 millimeter footprint, able to provide 4 amps of output current at high ambient temperatures. And then going down, we have the LMR 36506 in that very tiny 2 by 2 millimeter package. That is a 65 volt 600 milliamp device in the hot rod QFN. So that's our smallest total package size in both converters and modules in the YBN portfolio. And like I said, it's really pushing the boundaries of power density, and hence why we are focusing on power density at a total solution size after this and with the new package technology. And the micro-SIP package is the TPSM 265R1, is a 65 volt 100 milliamp power module that is newly released in a 2.8 by 3.7 millimeter footprint. So this also has the integrated inductor being a power module, and these micro-SIP packages are very popular as they are the smallest footprint from a module package technology, and we can talk more specifically about that, but this is our second device in this package technology released in our portfolio. We have a lot more in the low voltage team as well as in the mid voltage team at lower input voltages for power modules across the Buck switching regulators family, and something that we plan to continue going forward because of the very small footprint of the power module. So moving on, we just talked about how small our packages. You know, that sounds great and all, but what does that mean for you in terms of your total solution size? Because at the end of the day, BOM area, board space, and solution size is really what matters, not the package size. So what I did here was took a comparison from our WebBench Power Designer, which is a fantastic tool right on our website, ti.com, which can provide you a baseline power recommendation depending on your needs. If you want a more balanced design, small footprint, high efficiency, low cost, you can select different filters. It can provide initial simulations for efficiency estimates, BOM considerations as well. So it's a really great tool, and it's kind of a non-biased comparison that I've done here from previous generations to the new parts that I wanted to highlight, and I have highlighted in the last slide. So let's take a look at what these small package sizes mean in terms of total BOM area reduction. So in the top left, we have the 65 volt 100 milliamp comparison with the TPSM 265R1, which has fixed V-out options, compared to the silicon that we're using in the device, the LM5165, which is a little older and has been released out into the market for a few years. And of course, the power module is going to be the smaller solution integrating the inductor, but you can see the total BOM area is over 1/2 the size. So it's really driving home how much space you can save going the module route. And that is why we do see a lot of interest in this device and the microchip packages in very space constrained applications like field transmitters, proximity and position sensors. Moving on to the 60 volt 500 milliamp comparison, where I have our 60 volt 1.5 amp TPSM 5601R5H power module and the LMR 36506, which is newly released. And comparing it to the older generation, the LM5166, you can see that both the power module and the converter have a significantly smaller BOM area. And although it may not seem like a ton, you know, with 20, 30 millimeters squared can make a large difference. And as we know, you can further optimize these solution sizes, which I'll talk about in the device overviews, but this is just the standard WebBench, not playing around with the design at all. And you're getting a 20 to 30 millimeter squared reduction over the previous generation, which is again, just driving home the power density message that I'm conveying here with our new package technologies as well. And then in the 36 volt 4 to 6 amp space is kind of where you're going to see the biggest reduction, the largest reduction, and it's pretty impressive. So here I have the TPSM 53604, the 36 volt 4 amp module, our LM60440 36 volt 4 amp converter, those both in the enhanced hot rod QFN package, and then the LMQ61460, which is up to 6 amps with the integrated bypass capacitors for EMI performance. And comparing that to a previous generation LM73605, you can see that all of the newer devices, and especially the power module, are under 200 millimeters squared of total BOM area, and the module being closer to 100 millimeters squared and likely could be less than 100 millimeters squared. Again, this is just what WebBench is spitting out, but it really shows the LM73605, which isn't even that old of a device, is greater than 300 millimeters squared of total BOM area. So it's pretty much 2x the size for almost all of these newer devices. And it really shows we are pushing power density, and it is translating from package size to a reduction in total solution size, which in the end provides you more flexibility as a designer when you have reduced board space for your power and your buck to have room elsewhere in your design. So going on to the specific one-pagers, we call them the device overviews. I've talked about these devices already, but just going to highlight some of the specific features that might be of interest and further can reduce the total solution size for you. The LMR 36506 I've mentioned is in that super tiny 2x2 millimeter hot rod QFN package, being a 65 volt 600 milliamp part, also has a 300 milliamp option as well. It has low IQ. In terms of features, it has adjustable switching frequency, which is probably the most important. So you can play around with what switching frequency is going to provide you the best sweet spot in your design. Maybe you really don't have that much space at all, and you need to operate right at 2.1, 2.2 megahertz, so you can select the smallest inductor. That's going to give you the smallest total solution size. and really gives you that flexibility again in design, or maybe efficiency is more important to you and you're going to operate a little lower. And we also have fixed output voltage options, which are very convenient for the common 3.3 volt and 5 volt industrial rails, or we have the adjustable output voltage option as well, but that can also further reduce the solution size, eliminating the need for a couple of resistors and just simplifying your design as well. But as you can see on this kind of 3D image, with an optimized solution size, we can get under 50 millimeters squared, so 7 by 7.5, or that's right at 50 millimeters squared roughly of board space. So even smaller if you optimize the design and likely operate at a higher switching frequency. And then for the common 24 to 5 volt rail at 1 megahertz, we can get right around 90% efficiency. So high performance, full feature set, and very small size in the LMR 36506. And we have gotten a lot of interest of this device already in the broad factory automation space, as well as the more space-constrained field transmitters and sensors applications. And moving on to the LMQ61460, I mentioned is our first integrated capacitor converter for enhanced EMI performance. It also has good IQ performance as well, and importantly, the adjustable switching frequency from 200 kilohertz to 2.2 megahertz. And on the automotive versions, there are some fixed output voltage options as well as spread spectrum. And being that this is the silicon is the LM61460 cruise line is very popular, and it also has the adjustable slew rate control on the ART boot pin, which allows you to kind of play around with the EMI and efficiency. So not only are you getting a more power dense solution with the integrated caps and a very power dense 3.5 by 4 millimeter package, you can also, since you have those caps to meet the EMI requirements, adjust the slew rate to optimize your efficiency as well and reduce the power dissipation from this device. So it gives you a lot of flexibility in design, especially if you need to be up in the 4 to 6 amp output current range. And again, is popular across broad factory automation, as well as in some of the more performance-driven markets, such as medical imaging, test and measurement, and aerospace and defense. So this is just kind of highlighting what features we have on this device for great EMI performance, and I've mentioned that as well. So it has pseudo-random spread spectrum, the hot rod package, which eliminates the bond wires, a symmetrical pinout, as well as the slew rate control to kind of play around with the efficiency in EMI balance on the ART boot pin. And then here with the high frequency integrated capacitors with the poor layout, we've shown that you can get up to a 5 dB improvement with the integrated caps. So just kind of highlighting the advantages of this device. And just quickly showing how the capacitor location impacts EMI performance. Because we're integrating it in the package, in the die, it really minimizes the ringing at the switch node. And as this graphic shows, you know, from the first, you have a couple, you know, millimeters in separation, which is it's gonna do some job on the EMI performance of the ringing. But when you really integrate it within the package, that's minimizing the effect to the greatest degree. And that's something we've seen a lot of popularity with our power modules as well. And we're just taking that to the next step with the converters. And thus having this integrated in the package, of course, like I mentioned, also minimizes the total solution size. Next up would be the LM60440, like I mentioned, is our first converter in the enhanced hot rod QFN package, which also has wettable flanks. And as you can see on the larger image here, one of the reasons why we have the good thermal performance is the large thermal pad on the bottom of the package. And what I showed earlier was that we're able to get higher output current at less derating at higher ambient temperatures due to this package technology. So it's just extending the output current capabilities in that same 3 by 2 millimeter footprint that you're able to get with the previous generation LMR 33630. So for any high ambient temperature required applications, some more harsh operating environments, we've gotten some interest here, as well as just general purpose wide VN buck converter power supply needs in the PLC, industrial PLC markets as well. And this one has also some flexibility in switching frequency, having 400 kilohertz and a 1 megahertz option available. So moving on to the power modules, the TBSM 53604, like I mentioned, is our first power module released back at the end of 2019 in the enhanced hot rod QFN package. So really setting the groundwork for our power modules going forward. And this is a 36 volt 4 amp device in a 5 by 5.5 millimeter footprint. So it's really reducing the package size of the power module, which in the end leads to a much smaller solution size. So it can be 30 to 50% smaller than discrete implementation, 30% smaller than our competitor modules. And it also, because the improved thermal performance, has best-in-class efficiency at 24 to 5 volts out at 3 amps. And being a power module with integrated capacitors, it has good EMI performance as well. So meeting your CISPR Class B radiated emission specs pretty seamlessly, even if you don't have the flexibility to have the most optimal layout. And as you can see from the EVM, you can have a pretty simplistic layout with the input and output caps on this device to get the total smallest solution size. And so far, we've seen a lot of interest in the broad factory automation on this device, and we expect that to continue going forward. But most importantly, this, like I said, this kind of laid the groundwork for the package technology by getting out into the market first. And then in the same footprint is the TBSM 5601R5H that just begun sampling on TI.com. And this is a 60 volt 1.5 amp power module based on the LMR 36015 silicon. So same 5.5 by 5 millimeter footprint, high ambient operating temperature range for power modules. And it has a bit of flexibility. It has a 1 to 6 volt adjustable output range that's operating at 400 kilohertz for better efficiency performance on your 3.3 5 volt common rails, as well as a higher switching frequency for more of your higher output voltages at 1 megahertz. So this one should be releasing in 2021, and we expect continued interest as well in the factory automation space, but also in medical and aerospace and defense. And we do have a minus 55 degrees C rated option available on this device, as well as spread spectrum as well, another option to further reduce EMI on your design. And this is just a kind of a cool slide highlighting the advantages. I know we're wrapping up here in a minute or two, but you can see against our competitor power module, the TBSM 53604 in the enhanced hot rod QFN package has higher output current at less derating, with less derating. So it's operating higher output current, higher ambient temperatures, and it's actually in a smaller package. And a lot of that is due to the higher percentage of thermal contact on the board due to the large thermal DAP on the bottom of the enhanced hot rod QFN package. So our last device is the TBSM 265R1. This is newly released, our 65 volt 100 milliamp power module in the very small 2.8 by 3.7 millimeter microsip package. This also has fixed V-out options to further reduce your total solution size for the common output voltage rails. And we can have, as you can see down here, a single side layout in the 20 to 25 millimeter squared space for total solution size. So really minimizing your total solution size if you're only needing low output currents at around 100 milliamps. So a lot of interest in the sensor space and factory automation on this device. And then the last slide here is just the embedded module technology. So the microsip package, how are we able to get it that small? Well, we're integrating the silicon within, we're fully integrating and embedding the die within the substrate in the PCB, and then we're constructing in a 3D construction the inductor on top. So some customers, they receive the module and they think they're only getting inductor, but really they have the die embedded in the substrate, which provides us the total smallest solution size for these power modules and something that a lot of customers really enjoy the benefits of. So thank you for joining. I hope this was helpful for you and a good portfolio update on how the WideVN Buck Switching Regulators team is putting an emphasis on power density via our package technology. As Emily said, you can visit ti.com/new product update and PU to see this recording and other information on our new product update series. Emily, I'll let you close it out. Sorry if I stole your thunder there.
No, thank you, Tristan, and thank you everybody for attending today. Just a reminder, we hope to see you next week, and the next topic is real-time computing and web services with cost-optimized Satara processors. So thank you for joining, and like Tristan said, check out this site later today for the PDF version of the slides and the archived recording. Have a great day.